Hello everyone, welcome back to the another session in Principles of Programming Languages. Today we will be going to talk about the next continuation topic, which is overloaded subprograms and generic subprograms. This topic you will find in third unit as seventh topic. Now, so with this video we will close the design issues. The last three design issues are what? Can subprograms be overloaded? Yes. Overloaded subprograms can be overloaded, and there are languages which executes when you find the same subprogram with the different parameters. That we'll see how subprograms can be overloaded. And the next is about, can subprograms be generic? Yes. So that's what we learned, polymorphism. In concern to the object oriented programming languages, you already might have heard about polymorphism. So polymorphism is what? We'll have many forms of same type of things will be seen, many forms. So that also we'll say it is generic form. So that part we'll going to discuss. And the next is about if the language allows nested subprograms or closures supported. So these three things we'll be going to cover in this video. Now let's get started. Now what is a overloaded subprogram? Overloaded subprogram definition is what? It is for 2 marks, short question. Many of times this question has been asked by the universities for end semester examination. Define overloaded subprograms and give some examples of overloaded subprograms. Now an overloaded subprogram is a subprogram that has the same name as another subprogram in the same referencing environment. So again we were talking about referencing environment. Referencing environment is what? Where we define the function, where we call the function is what referencing environment. When we define the function, when we define the variable of the function, we say it is local referencing environment. Now let's see, you will be going to find the subprogram with the same name and the same referencing environment. So there are three protocols what basically we will see with the overloaded subprograms issue. That is, it must be different. When a program is said to be overloaded subprogram, it must be different from the others in the number, order of types of its parameters, and possibly in its return type if it is a function. Now let's say function 1 is a subprogram and function 1 is the another subprogram. That's what overloaded subprogram. There are two subprograms what are existed, and this function 1 protocol is what? Number of the parameters, order of the parameter, type of the parameter should be different. Now I have taken the name of the parameter should be same, right? That's what we learned from the overloaded subprogram. Function 1 and function 1 is the same name, and the parameters of this function 1 are a comma b, and these parameters are no parameter for this subprogram. Now this is what the pure example of overloaded subprogram. A subprogram is existed with the same name in the same referencing environment. So having some different kind of parameters, here no parameter, or else you can say different data type of the parameter. Let's say this a comma b or belongs to integer, and these parameters some c you have, and this may belongs to the other data type. So having the same name is called as overloaded subprogram. The meaning of a call to an overloaded subprogram is determined by the actual parameter list, the type of the return value, and although it is not necessary, overloaded subprograms usually implement the same process. Now let's see what programming languages will allow basically this overloaded subprogram. There are programming languages which are C++, Java, Ada and C# include predefined overloaded subprograms. For example, many classes in C++, Java and C# have overloaded constructors. So let's take some same parameter profile. Now I'll give an example. We'll move to the examples of language by language. We'll see the example. So let's see the example from C++. This is what the syntax structure of C++ language. So if you find this syntax, this syntax will give you about two functions. fun and this fun, these are what two different functions, but having the same name. As far as overloaded subprogram concept is considered, function name should be the same. Parameter profile can have a different number, right? So what is parameter profile? It can have invariant of different parameters. Here you can have number of parameters or one, and here you may not have the parameter. And here the parameter type is some float, here the parameter some integer. So parameter profiles can have some difference, but overloaded subprograms of what name can be the same. As far as C++ is considered, now look at this, function float b is equal to 0.0 and function with empty parentheses, and we call this function. Now the point is, which function will give, which function will get respond, or which function will get executed. So now this kind of things will throw an error. The reason is what? You have an ambiguity over here, repetition or else the duplicate forms you have here, right? And now let's see the other language, how it will executes. So we'll take the other C++ code. In C++, I'll take the other example. Let's say that function is the subprogram. Function is the subprogram where it returns some integer data type, integer function and float function. Now there are two functions. Now this is what? The first fun is integer data type and this fun is float data type. So when C++ program has two functions named fun, both take an int parameter, but one returns an integer and the other one returns. It returns integer, it returns float. The program would not compile because the compiler could not determine which version of fun should be used. So these kind of difficulties we'll face in C++, and that's what will give type checking as a major issue in the languages. Before we pass a parameter, we'll check the data type of it. And even when you are calling the subprogram, let's say that you have two subprograms in the program and you wanted to call a subprogram. So we will be very sure by passing the actual parameter. So we will be pass the values to balance the parameter profile what we were given. As far as the example is considered, when you call the function with no parameters, function calling procedure should be also appropriate. And when we call the function with the floating type of data, even the function call should also be appropriate. When you say that you are putting the empty parentheses and you are not calling any of the parameter inside of it, compiler will throw you an error. Now let's see about generic subprograms. The name itself, it says that we will be writing a general form of a subprogram, and this subprogram general form can be manipulated or else can be given by the different scenarios. Now let's see about the same. One way to increase the reusability of software is to lessen the need to create different subprograms that implement the same algorithms on different types of data. We'll have the same general form and we'll keep on modify the data on that general form. Let's take some example. So before we see example, we say about a polymorphic subprogram. Our example is what? For example, a programmer should not need to write 4 different sort subprograms to sort 4 different arrays. It is natural, right? When I wanted to sort 4 different arrays, we'll not take 4 different subprograms. What we'll take? We'll write a generic subprogram, or we'll define a generic subprogram, and that subprogram will get called by 4 different parameters. So this is what, wherever you write that generic subprogram, we say it is generic one. So generic one is what? We will be take some different kind of data into it. Let's say an example. We'll take the same algorithm. Let's take that I wanted to perform addition. Now I'll write what are the necessary steps which are required for addition. Now this is what general one. And this general one can have different datas. Add 5, 6 is my other data. Add 17, 15 is my another data. Now when see this one, you have only one algorithm or else one block of the code where this block of the code will get used by many datas. And this is what we say generic subprogram. And you also can have the idea of polymorphism over here. A polymorphic subprogram takes parameters of different types on different activations. Overloaded subprograms provide a particular kind of polymorphism called ad hoc polymorphism. Overloaded subprograms need not behave similarly. Languages that support object-oriented programming usually support subtype polymorphism. This is important. Languages which are support object-oriented programming usually supports subtype polymorphism. What is subtype polymorphism? It means that a variable of type T can access any object of type T or else any things which are derived from the T. That is called as subtype polymorphism. Now, a more general kind of polymorphism is provided by two programming languages which are Python and Ruby. Now, we will see some examples how this parametric polymorphism is provided through a subprogram that takes generic parameters that are used in the type expressions that describe the types of the parameters of the subprograms. And these are the programming languages which support generic subprograms. C++, Java, C#, and F# will give a subprogram, generic subprogram template where the algorithm will be same. We apply different data on the same algorithm. Right. Now I'll show you some examples how generic subprograms are being written from language to language. Then this syntax is what from C#. In C#, if I wanted to take any when I wanted to take some class, then I should follow the common template, common general form to create a class, right? So that is what a general form or a generic functions in C++ have. Descriptive name of template functions, which is template and template parameters. So this is what general one, generic one. And in this one, a function definition that may include the template parameters, this. So here, what I can put, what is my data? This is what existed template or else existed generic subprogram. Now I can modify this to according to my requirement. Now I can say it is, in the place of template, my template is what? Class. In the place of parameters, I'll write some identifier. Now I'm using this one, I'm deriving this thing from the existing one. Hence it is called as a generic one. And also I can take the other one, type name. Here it is, type name and identifier. The class form is used for type names. The type name form is used for passing a value to the template functions. So this is the way how we will use generic subprograms, right? And let's see about the other languages, how it will use the generic ones. So this syntax we were taken from Java, and here template class type. Now look at this. So here in this template, I can take my own syntactical structure. Let's say that I wanted to write a template for some max subprogram. Now, in the case of this, so template, in the case of that, I'll write type max. Type is what? Type is a keyword to mention the return type of a subprogram. Now, class type. So here we'll generally write the parameter profile, and these are what your parameter profile. Now, return first greater second, ternary first colon second. So this is what type is the parameter that specifies the type of data on which the function will operate. This template function can be instantiated for any type for which the operator greater than is defined. If you don't have this greater than, it can be, if you have greater than, it will be restricted to only the parameters which have greater. If you don't have that greater, still it is generically applied for whatsoever variables you wanted to take into the subprogram. And this is what? So this is what the application of my data, and this is what your generic data, right? And there are the other programming languages, what you can see, which is Java, generic class T. I wrote my data, which is public static. T is what? The name, and do it the list of the things. So this is what in from C#. Even from C# class, my class, public stat T, do it T, and this is what generic syntax. So generic subprograms will give you we'll be having a common algorithm. We'll be having a common subprogram structure where we apply our requirement into it. So this is about generic subprograms. Thank you all.